Hi, welcome back to the channel. I saw this question on how to find the area bounded by a curve and the x-axis, and I feel it will be great I shared with you. It will help us x-ray another application of integration. That said, let's get into class. The question says we should find the area of the finite region between the curve with equation y is equals to 20 minus x squared and the x-axis. We're going to divide this process into two. We look for the point where this curve will intercept the x-axis and also intercept the y-axis. Now, then after which we'll now draw the curve. Now note that the point where the curve intersects the x-axis is at when y is equals to 0. And the point where it intercepts the y-axis is at when x is equals to 0. You see this as we work on. Now, first, let's look for when it intercepts the y-axis. That's at when x is equals to 0. Now, when x is equals to 0, the y will become 20 minus 0 minus 0 squared. So that y obviously is equals to 20. This is at the point when x is equals to 0. Now, let's check when y is equals to 0, it will occur at the point when 20 minus x squared is equals to 0. Now, to get the values of x at that point, we'll have to factorize this equation. Now, let's just use factorization method to get the values of x, so that 20 times minus x will become minus 20x squared. Now, I'll be looking for the factors of minus 20x squared such that when you add them up, you get a minus x. When you multiply those two factors, you get minus 20x squared. Those two factors are minus 5x, and 4x. So that my equation now can become 20 minus 5x plus 4x minus x squared is equals to 0. Now, all I've just done is I've replaced my minus x with minus 5x plus 4x. In case you're finding it difficult to understand, I have done a video on how to factorize quadratic equations. I'll place a link to that video in the description below. Now we can now continue factorizing. If I bring 5 out here, I'll have 4, sorry, not 20, 4 minus x plus. Now here I have 4x minus x squared. I'll bring x out again. I'll be left with 4 again minus x equals 0. So that the basic factors of this equation are 4 minus x and 5 plus x equals 0. Now I can now deduce that 4 minus x is equals to 0. And when 4 minus x is equals to 0, obviously x is equals to 4. And 5 plus x is equals to 0. Also, when 5 plus x is equals to 0, obviously x is equals to minus 5. Now, so we can now conclude that when y is equals to 0, my x values are minus 5 and 4. Now we can now draw our curve. Remember, we got the values for when x is equals to 0, y is equals to 20. That is, my curve is crossing at here will be 20. And when y is equals to 0, x is equals to minus 5 and 4. Now, so the region we're actually looking for, the finite region we're looking for, is this region bounded by x-axis and the curve. And it's going to rotate between 4 and minus x. Now, like I did explain, it's an application of integration. So that now to find the area bounded by this curve, we'll now use integration. We're saying that my area bounded by that curve A is the same thing as the integral of my y gyrating between 4 and minus 5, which is the same thing as the integral of 20 minus x squared with respect to the x moving between 4 and minus 5. So that my area in this case is the same thing as integrating. When integrating 20. 20 is actually a constant. It becomes 20x. Now integrating minus x also becomes minus x squared over 2. And integrating x squared, it becomes minus x raised to power 3 over 3. You can check the description below also for our lesson on integration. I'll place a link to that lesson. Now, the area A bounded by that curve will now be the same thing as, in place of x, I can begin to substitute for 4 minus x squared. That will be 4 again over 2 minus 4 raised to power 3 over 3. Now, minus, we'll substitute again for 5. 20 into 5 minus 5 raised to power 2 over 2 minus 5 raised to power 3 over 3. Now, so that my area A this time is the same thing as 20 times 4, that's 80, minus 16 over 2, that's 8, minus 4 times 4 times 4, that's 64 over 3, now minus 100 minus 25 over 2 minus 75 over 3. If you use your calculator, you get the area of this curve to be the same thing as 243 over 3. 243 over 3. I have decided not to attach any units to it because the question did not specify units. The question had specified probably my dimensions in meter, then my area will definitely be meter squared. And if it is in inches, it will be inches squared and thereabout. Thank you for staying with us. With this, I hope you understand how to go about finding area bounded by a curve and a line.